Ladies and gentlemen, Swissense is now on stage and they will present their 5-minute pitch.
Okay, so hello everybody. I'm Remo. Here is Hugo. So we will present you a bit our work. So our team is Swissense. We are from Switzerland, from the EPFL. The team, I will speak more about. So we are a very international team. We have people from Indonesia, from Macedonia, from Russia, even from Saudi Arabia, and of course we are also from Switzerland. And in the team we have most of the people microengineering, also a management and a material science. So I will also explain you a bit more how to use our biosensor. So here you can see the biosensors, and on the bottom right the chips that goes with the biosensors. Basically, we take the chip, we load our blood sample that we need to test in the chip. We put the chip into the machine, we close the machine, and then with the computer software we can start, and the test is done all automatically, and we have the results showing on the screen on the computer. A bit more, so it's a plug-and-play, very easy-to-use system. A bit more in detail, so inside of the machine we have an electronic system which is controlling some pumps to pressurize air, and also valves, so air switches, which allows to push air into the chip, and this will make some microfluidics into the chip. So you may wonder what's microfluidic. Microfluidic is basically plumbery, but in a micro scale. So he will explain a bit more after. The detection is made with a USB microscope. So it's a small microscope under the chip, which will collect the light emitted from the chip. And everything is connected to the computer, and you get the data, so the concentration of your blood sample on the computer that you could send to a doctor or wherever you need. So I will leave the floor to Hugo, who will explain more about the working system inside of the chip.
Okay, let's have a look now inside the chip, what's happening. So our channels are made of valves and mechanical systems that are blocking the surface at certain region. You hear the black dots, which is very useful for the chemistry. We also have switches which allows us to control exactly where liquids is flowing, and we can flow different liquids at specific regions inside the channels. Let's have a look at the biology at the surface. So when you receive the chip at home, it's like this. There is some capture antibodies already at the surface, which are specific to the anti-proBNP and detect only this one. When the blood is flowing, the anti-proBNP attach to those specific regions, concentrating the signal. Next, using our valve system, we flush fluorophores inside, which attach to the proteins. And finally, the more protein you have, the more fluorophores are attached to them, and the more light we can collect with our camera. This signal gives us the amount of concentration you have in your blood of this protein. Finally, the main advantages of our biosensor is that we can use only blood sample inside. It's also very simple to use with our plug-and-play system. Also, in the future, we can imagine detect several molecules at the same time with the same amount of blood, with only one test. Finally, thank you for your attention. If you want to see more in details the technology, please come at our stand and feel free to ask any questions. A few questions? No? Come see us.